Okay, hi Dr. Sharma, this is Carlene doing my video chapter review for chapter 3. Things that I struggled with in this chapter, even though it felt really intuitive, the limiting reactants, I just kept slipping up on determining like the mass between switching back and forth between mass and moles for some reason. What I did with this, I've just been relying heavily on the textbook because yes, the slides are helpful, and even some of the reviews in class I find really useful for me, especially as I review the math back at home. I still end up getting things a little bit mixed up. I think it's just part of the learning curve, I guess you could say. So still working on reviewing that, my limiting reactants, but so far so good. I feel pretty confident about it. I just I keep forgetting some things. So I'm some steps when it comes to reviewing the math. So for chapter 3, I decided to review empirical and molecular formulas. Okay, so an empirical formula shows the simplest whole number of a ratio of elements in a compound, and a molecular formula shows the exact number of atoms for each element in a molecule. So empirical formulas are kind of like the base, you could say, like the starting point of what combination of elements or what kind of molecules can be formed, because it changes as the numbers differ. So from there, I'm going to go ahead and do a little math problem and tune you into that. All right, so I went ahead and opened up the textbook to pull up a problem that I saw. We're going to go with practice problem A. It's the combustion of a 28.1 gram sample of ascorbic acid produces 21.1 grams of carbon dioxide and 11.5 grams of H2O. Determine the empirical and molecular formulas of ascorbic acid. So right now I'm highlighting the information that I know, details that are important for me to fall back on as I move forward with the problem. And we're gonna open up my whiteboard, my digital whiteboard, and all right, so let's go ahead and write out the information again, just so I have it, something I can refer back to. So we have 28.1 grams of ascorbic acid with 76 grams per mole for the molar mass. We also know that we have 42.1 grams of carbon dioxide along with 11.5 grams of H2O. From here, we're going to determine what the mole of each of these molecules are. So to do that, we will find the molar mass. This is me doing such. All right, so now that we found the mole of each of these molecules, we're gonna, since we see that there's 0, or oxygen I should say, in each of these molecules, let's determine first what each of the elements that they don't share is. And now we'll do the same for the other side. It'll be the mass divided by the molar mass gives me 6.38 moles of H2O, excuse me. So now to find what C is, we will times it by how many C's we have. In this case, we only have one C times the molar mass of C. And that will give me how many grams of carbon, I keep saying C, but how many grams of carbon exist in this molecule. So it's going to be 11.5 rounded grams of carbon. So we'll do the same thing on this side. We see that we have two H's or hydrogens, so we are going to times this by 2 and then by the molar mass of H. This gives me 1.29 grams of hydrogen. So altogether, we can combine what we know we have for carbon and hydrogen, and this is going to give me 12.79 grams. And we know that we have, I believe, 28.1 grams of our total substance. So let's go ahead and subtract 12.79 from our 28.1 gram. This is going to give me 15.31 grams of oxygen. So now that we've done that, let's determine the mole of the elements that lie in our new molecule. So because C is not a molecular carbon, we only have to multiply it by 1 to achieve our mole. Whereas for H, it is a molecular H, so we have to multiply it by 2. So to determine oxygen, we have to take the mass that we know by the molar mass. That gives me the mole of oxygen. Now, to find the empirical formula, we have to pick the smallest element, or the smallest mole, and divide that by each of the present elements. So in this case, we see that, I picked C as my smallest element, but I see now that oxygen is my smallest element. Thankfully, both of these are similar in numbers, so they're going to give me the answer that I'm looking for. I need the middle digit to be closest to a whole number. So I know that 0.3 is a third, so we're going to go ahead and multiply it by 3. So that will give me C3H4 and O3, giving me the empirical formula of C3H4O3. Now, in order to find the molecular formula, I need to find the molar mass of all the elements here for ascorbic acid. All of these combined give me a molar mass of 85.04 grams of ascorbic acid. So I know that I have, for ascorbic acid, 176 grams for mole mass. Whoops. And we have to divide that by what we know our empirical formula is. This gives me the answer of 2.07. So I'm going to take the number 2 and multiply the subscript, I should say, by 2. And this gives me C6H8O6 as my molecular formula for ascorbic acid. So we can go ahead and check out the textbook. And that is the correct answer. But thanks so much. I hope this wasn't too much.